Hello and welcome back to Mr. Bell Physics. Today we're going to be talking about density. So let's start off with the question of what is density in the first place? See, everything in the known universe is made of something called matter. And all that matter is just stuff, right? Atoms, protons, neutrons, electrons, etc. Now, different types of elements have different properties. And one of those things is different density. All density is a measurement of how much matter takes up a physical space. So everything in the known universe has matter, has a known mass, a measurement of how much matter there is, but also has a known volume. How much space does that thing physically take up? All density is an object's mass divided by its volume. The formula for it looks like this. We have density, represented here with the Greek letter rho, equals mass divided by volume. Now, for our purposes, we're going to be measuring density in grams per cubic centimeter. And that's because these numbers are usually pretty easy to work with. So for mass, we want to make sure that we are always working in grams. And for volume, we should always be working in either cubic centimeters or milliliters, whichever one floats your boat, because 1 cubic centimeter and 1 milliliter are the exact same thing. Now I'm going to keep my formula right over here for later, but I want to show, physically speaking, what does density actually do. So what I have here is a beaker just filled with a bunch of water. Okay. Now water has a known density of 1 gram per cubic centimeter. Meaning that every single cubic centimeter of water that exists in this beaker right now weighs exactly 1 gram. If I take an object with a higher density than water, for example, this piece of metal, and I drop it into the beaker, what's going to happen is it drops straight to the bottom there, as you can see. However, if I then take something with a density lower than water, for example, a piece of wood, and I drop it on top, it floats. See, for objects to sink in other objects, they need to be more dense. Okay, gravity is going to try to pull them down, but they need to have more stuff in their known volume than the stuff they're trying to sink in. This type of process is really important when it comes to understanding how planets are formed and why, for example, the Earth has a core made out of mostly iron and nickel. And those are the most dense materials, so they sink all the way down. It wouldn't make a whole lot of sense for water to sink through rock. So, for our purposes in this class, we need to be able to know how to do calculations with density. So, we're going to use our formula here, and we're going to use a real world example to calculate the density of an unknown metal cube of something. So, suppose I have a cube that has a known mass of 240 grams. So, my mass would be 240 grams. And let's say I have a known volume for that cube. Now, there's a few ways we can go about doing this. Okay. Number one, if it's a cube, we can measure all the side lengths and do length times width times height. So if I have a cube like this, and I know length, and I know height, and I know width, I can multiply all three of those numbers together, right? So volume could equal length times width times height, which for a cube, all these numbers will be identical anyway, because it's a cube, right? It's the same exact side length on all sides. If I wanted to do that mathematically, I could absolutely do that. But there's an even easier way I could do this. See, instead what I could do is I could take a container filled with water, say a graduated cylinder. So that allows me to very precisely measure volume. So let's say I have a graduated cylinder and it has some water in it. up to right about here. And let's say that that is 50 milliliters. Or something akin to it, right? Then let's say I place my object into the graduated cylinder. Again, right? Same amount of water in it. I'm just adding the additional cylinder. That water level is going to rise for the same exact reason that when you take a bath or go into a pool or something like that, when you go into that body of water, the water rises. You're displacing the volume. So let's say it goes from 50 meters to, or 50 milliliters, all the way up. Let's say this is like 80 milliliters. The only thing that's changed is I put something into this one. Okay, there's like a rock or something like that sitting in there. What that tells me is that the volume of that rock has to be the difference here. So I would do 80 minus 50, and I would get 30 milliliters. And that will be my volume of my object. Of course, if the problem already gives you the volume, you don't need to do any of this. But if the problem doesn't give you the volume, or you're trying to find it experimentally, these are various ways you can go about doing it. So for this problem, our volume is actually exactly this, okay? We put it into a graduated cylinder. Water level started at 50, went up to 80. So therefore, my volume is going to be the difference. So 80 minus 50 equals 30 milliliters. So that is my volume, and that's how I can figure out my volume. So that's well and great and all, but let's actually get this calculation done now, right? Let's actually figure out how dense this object is, and more importantly, if it's going to sink or float in water. So erasing this, my formula is still right over here. Density is mass divided by volume. In this case, I don't know density, but I do know mass and I do know volume. Okay, my mass is 240 grams. My volume is 30 milliliters. So let's go ahead and plug in and solve. So density is unknown still, so we can just leave that be, equals our mass number, 240, divided by our volume number, 30. Now, at this point, I can already realistically kind of get an idea of what I'm dealing with here. I could probably take a pretty good guess. This is not going to float in water. And the reason why is because I know the density of water is 1. I know anything above 1 is not going to float. It's going to sink. I know for a fact that in order to get a number less than 1, the bottom number here has to be bigger than the top number. And that's just not the case here. Okay? The top number here is significantly larger. So this thing is definitely going to sink. But let's see how hard it's going to sink. Let's actually do out the math here. So all I'm going to do in my calculator is 240 divided by 30. And when I do that out, I get a pretty clean answer, actually. I get, okay, these go away, and I get just a straight number. I get 8. Now, some people would think we're done here. Okay, we have solved our answer. Our math is done. But this is a number without a unit, which means that right now, it's meaningless. It doesn't give us a clear picture in terms of what I'm actually dealing with here. So, in order to give this number meaning, I need to put a unit onto it. So, that unit is going to be grams divided by cubic centimeters. Because that's literally what I did. This is grams divided by cubic centimeters. So, I put that into my units, grams per cubic centimeter, and that will be my answer. This is a very dense metal, essentially. So, that is how you would go about solving a problem for density. Of course, there are other intricacies that we could deal with. For example, if you're solving for mass or volume instead of density. But for our purposes, we're just going to worry about solving for density for now. So that's the end of this video. As always, I hope that you enjoyed, and I hope that you were able to gain something out of this. Make sure you smash that like button. Make sure to hit that subscribe button and make sure to ring the bell so that you are notified whenever there is a new video. As always, thank you so much for watching. I'll see you in the next video.